In this module, we will learn about hypothesis testing, mean, one and two tail test and p-values. You are aware about the basic concept of hypothesis testing along with the two types of errors involved and significance level. In this module, you will additionally learn about the large and small sample tests for the population mean.
After studying this module, you shall be able to know about testing for single mean, know about large sample test, know about testing with normal population distribution, know about the p-value.
Now let us commence our module with test about single population mean. Let us take case 1, a normal population with known sigma. A test of hypothesis is about a population mean involve testing the null hypothesis HO is to mu is equal to mu O, which is the null value. The sample mean is the test statistic used to test the hypothesis. The random sample of size n is taken from the normal population and is known as sigma. In this case, x bar also has a normal distribution with mean mu. X bar is equal to mu and standard deviation is equal to sigma divided by root n. Standardizing to get z under the assumption that HO is true, that is mu is equal to HO, we get z is equal to bracket open x bar minus mu O bracket close sigma divided by root n. If HA is to mu is greater than mu O, then HO will be rejected only if x bar value exceeds mu O by a significantly large amount. Otherwise, HO is not rejected. This implies that Z will be positive and large. The rejection region takes the form of Z is greater than Z alpha, where Z alpha is the cutoff value chosen to control probability of type 1 error alpha at the desired level. This is called the upper tail test. On the other hand, for HA is to mu, where mu O is greater than mu, x bar will be quite less so that Z becomes negative. The rejection region takes the form of minus Z alpha greater than Z. This is called the lower tail test.
For the null hypothesis, HA is to mu is not equal to mu O. HO will be rejected if X is significantly different from mu O from any of the sides. This happens when either Z is greater than Z alpha by 2 or Z is less than minus Z alpha by 2. This is known as the two-tailed test. The Z values plus Z alpha by 2 or minus Z alpha by 2 are called the critical values as they are critical in deciding whether or not to reject. For this reason, rejection region is also known as the critical region. Before we outline the hypothesis test procedure for different alternative hypotheses, test procedure is case 1. Null hypothesis HO is to mu equal to mu O. Test statistic value is Z is equal to minus mu O divided by sigma by root n. Alternative hypothesis HO is equal to mu greater than mu O. The rejection region is that ZA is greater than equal to Z alpha, which is the upper tail test. HA is to mu is less than mu O, and the rejection region is that minus Z alpha, the lower tail test, is greater than Z. HA is to mu is not equal to mu O. The rejection region is that either Z is greater than Z alpha by 2 or minus Z alpha by 2 is greater than Z, which is the two-tailed test.
Question 1. A motor car company claims that car's average speed is 35 miles per gallon mpg of petrol. In a sample of 100 cars, it was found that the average is 32 mpg. If the speed is normally distributed with standard deviation of 4 mpg, test the claim at 0.05 and 0.01 level of significance.
Solution. First, HO is to mu is equal to 35. HA is to mu is not equal to 35. Second, Z is equal to minus mu O by sigma by root n. 3. Reject HO if Z is less than equal to minus Z 0.05 or minus Z 0.025 is greater than equal to Z, where alpha is equal to 0.05. Z 0.05 is equal to 1.96. If alpha is equal to 0.01, reject HO if Z is greater than equal to Z 0.005 or minus Z 0.005 is greater than equal to Z, or Z 0.005 is equal to 2.575. 4. Z is equal to 32 minus 35 divided by root 100, which is equal to 7.5. Hence, minus 7.5 is less than minus 1.96. HO will be rejected at 0.05 level of significance. Also, minus 7.5 is less than minus 2.575. Hence, HO will again be rejected at 0.01 level of significance. The data is significant enough to reject HO at both levels of significance.
Question 2. In the previous question, test the claim that the performance of the car has gone down at 0.05 and 0.01 levels of significance.
Solution 1. HO is to mu is equal to 35. HO is equal to that 35 is greater than mu. Second, Z is equal to minus mu O divided by sigma divided by root n. Reject HO if minus Z 0.05 is greater than equal to Z at alpha equal to 0.05. Z 0.05 is equal to 1.645. Reject HO if Z is less than or equal to minus Z 0.05 at alpha equal to 0.01. Z 0.01 is equal to 2.33. 4. Z is equal to 32 minus 354 divided by 100, which is equal to minus 7.5. Since minus 7.5 is less than minus 1.645 and minus 7.5 is less than minus 2.33, HO will be rejected at 0.05 and 0.01 levels of significance respectively.
Now we will study case 2, large sample test. When the sample size is large enough and population variance is unknown, we can still use the Z test from case 1. In this case, neither of the conditions of normal population are known. Sigma are required. If the sample size n is large, standardized variable is equal to Z is equal to minus mu O divided by S divided by root n, has approximately standard normal distribution, where S is the sample standard deviation and used to approximate the population standard deviation. In this case, the test procedure remains the same as in the previous case. A large sample is denoted by a sample size of more than 40. Question 3. Light bulbs of a certain type are advertised as having an average lifetime of 750 hours. A potential customer has decided to go ahead with the purchase arrangement unless it can be conclusively demonstrated that the true average lifetime is smaller than what it is advertised. So, a random sample of 50 bulbs was selected that gave a mean as 738.44 hours and standard deviation of 38.20 hours. What are the appropriate hypotheses for this test? What conclusion would be appropriate for a significance level of 0.05? Does your conclusion change at the 0.01 level of significance?
Solution 1. HO is to mu is equal to 750. HA is mu is less than 750. Second, test statistic Z is equal to minus mu O divided by sigma divided by root n. Reject HO if minus Z alpha is greater than equal to Z at alpha equal to 0.05, Z 0.05 is equal to 1.645, at alpha equal to 0.01, Z 0.01 is equal to 2.33. Z is equal to 7.844 minus 750 divided by 38.20 divided by root 50, which is equal to minus 2.14. Since minus 2.14 is less than minus 1.645, HO is rejected at 0.05 level but not at 0.01 level, as minus 2.14 is greater than minus 2.33. Hence, consumer will purchase the bundle at 0.01 level of significance but not at 0.05 level.
Question 4. Manager of a certain city hotel reports that mean number of rooms rented out per night is at least 212. A sample of 150 night gives a mean value of 201.3 rooms and standard deviation of 45.5 rooms. At 0.01 level of significance, check the manager's claim.
Solution 1. HO is to mu equal to 212 and HA's mu is less than 212. 2 minus mu O divided by S divided by root n. 3. Reject HO if minus Z 0.01 is greater than equal to Z. Z 0.01 is equal to 2.33. 4. 201.3 minus 212 divided by 45.5 divided by root 150 is equal to minus 2.88. Since minus 2.88 is greater than minus 2.33, HO is rejected at 0.01 level. Manager's claim of at least 212 rooms being rented out per night is an overstatement.
Next, we will study case 3, a normal population distribution, when 40 is greater than n and sigma 2 is unknown. The Z-test for testing the population mean cannot be used. This is primarily because the central limit theorem cannot be invoked to justify the use of a large sample test. As a result, we have to use a t-test.
If x1, x2 to xn is a random sample from a normal distribution, the standardized variable t is equal to minus mu divided by s divided by root n has a t distribution with n minus 1 degrees of freedom.
With HO equal to mu is equal to mu O is tested against HA is to mu, where mu O is greater than mu. The appropriate test statistic in this case is the T, which is mu divided by S divided by root n. Here we use estimated standard deviation of x, which is S by n rather than sigma by n. If HO is true, the appropriate rejection region for which type 1 error probability is controlled at the desired level is given by T is less than T alpha n minus 1. Here minus T alpha n minus 1 is the lower tail T critical value. Also P type 1 error is equal to P, where HO is rejected when T is true is equal to P bracket open, where T
less than
minus T alpha n minus T when T has a T distribution with n minus 1 df is equal to alpha.
The one sample t-test. Null hypothesis HO is to mu is equal to mu O. Test statistic value T is equal to minus mu O divided by S divided by root n. Alternative hypothesis HA mu is greater than mu O. Rejection region for a level t-test. T is greater than T alpha. N minus 1 is upper tailed. HA is that mu O is greater than mu. Rejection region for a level t-test is that minus T alpha is greater than equal to T. N minus 1 is the lower tail test. HA is that mu is not equal to mu O. Either T is greater than equal to T alpha by 2, N minus 1, or minus T alpha by 2, N minus 1 is greater than equal to T, which is a two-tail test.
Question 5. The specification for a certain kind of ribbon call for a mean breaking strength of 180 pounds. If 5 pieces of the ribbon randomly selected from different rolls have a mean breaking strength of 169.5 pounds with a standard deviation of 5.7 pounds, test at 0.01 level of significance that the mean breaking strength is lower than assumed. Assume that the population distribution is normal.
Solution 1. HO is to mu is equal to 180. HO is to mu is less than 180. 2. T is equal to minus mu O divided by S divided by root n. 3. Reject HO if minus T alpha n minus 1 is greater than equal to T. T alpha n minus 1 is equal to T 0.01, 4, which is equal to 3.747. N minus 1 is equal to 5 minus 1, which is equal to 4 degrees of freedom. 4. 169.5 minus 180 divided by 5.7 divided by root 5 is equal to minus 4.12. Since minus 4.12 is less than minus 3.747, HO is rejected at alpha is equal to 0.01. This implies that the mean breaking strength is lower than specified.
Question 6. A random sample of 6 steel beams has a mean compressive strength of 58,392 psi, which is pounds per square inch, with sigma of 648 psi. Use this information and level of significance alpha is equal to 0.05 to test whether the true average compressive strength of the steel from which the sample came is 58,000 psi. Assume normality.
Solution 1. HO is to mu is equal to 58000. HA is equal to mu not equal to 58000. Second, T is equal to x bar minus mu O divided by S divided by root n. Reject HO if T is greater than T alpha by 2, comma n minus 1, or minus T alpha by 2 n minus 1 is greater than equal to T. T alpha by 2 comma n minus 1 is equal to T 0.025 comma 5 is equal to 2.571. 4. 58392 minus 58000 divided by 648 divided by root 5 is equal to 1.48. Since minus 2.571 is less than 1.48, which is less than 2.571, HO will not be rejected. The data is not significant enough to reject the claim that the mean compressive strength of steel is 58000 psi.
Question 7. A census of retail establishment in a particular month revealed that the mean monthly turnover of food stores was $2,500. A random sample of 16 such stores showed a mean monthly turnover of $2,660 and sigma of $480. Could you conclude that the mean monthly turnover has changed since the census? Use alpha is equal to 0.05 and assume normality.
Solution 1. HO is to mu is equal to 2500. HA is to mu is not equal to 2500. 2. T is equal to minus mu O divided by S divided by root n. Reject HO if T is greater than T 0.025 comma 15 or minus T 0.02515 is greater than equal to T, or T 0.025 comma 15 is equal to 2.131. 4. 2660 minus 2500 divided by 480 divided by root 16 is equal to 1.33. Since minus 2.131 is less than 1.33 is less than 2.131, the data is not significant enough to reject HO.
The p-value is the observed or the actual level of significance at which we reject the null hypothesis. Instead of first finding the critical value of a test statistic and comparing it with the calculated value to conclude whether null hypothesis is rejected or not, we first calculate the value of the test statistics and then find the smallest level of significance, which is basically the p-value at which the null hypothesis is rejected. Main advantage of using p-value is that there is no need to find critical values of the test statistics for different levels of significant alpha every time. We just need to compare p-value with alpha to check at what levels of significance null hypothesis is rejected and what levels it is not. Generally, the smaller is the p-value, the greater is the evidence against the null hypothesis, and hence greater is the probability of accepting the alternative hypothesis. In particular, we reject the null hypothesis if p-value is less than or equal to alpha, and do not reject the null hypothesis if p-value is greater than alpha. Now let us summarize what we have learned. The test of hypothesis about a population mean involved testing the null hypothesis. HO is to mu is equal to mu O, which is null value. The sample mean is the test statistic used to test the hypothesis. If the sample size n is large, standardized variable z minus mu O divided by S divided by root n has approximately standard normal distribution, where S is the sample standard deviation and used to approximate the population standard deviation. When 40 is greater than n and sigma squared is unknown, the z-test for testing the population mean cannot be used. This is primarily because the central limit theorem cannot be invoked to justify the use of a large sample test. As a result, we have to use a t-test. The p-value is the observed or the actual level of significance at which we reject the null hypothesis. The smaller is the p-value, the greater is the evidence against the null hypothesis, and hence greater is the probability of accepting the alternative hypothesis.